Okay, we're going to be looking at graphing in 3 dimensions, and this is, I think, is really cool, and we're going to be using some computer software to make it even cooler and more visual. But turn your brains on because you're going to need to be thinking in a much different way. This is very visual. So for those of you that are analytical and like to crunch away on equations, this is a different experience. For those of you that love geometry, I think you'll find this most pleasing. So let's get started though with total numbers. So let's imagine that we've got some function f of xy, and that equals x squared plus y squared. So f of xy, we'll call that z. So it depends on two variables, x squared and y squared. And just like we did when we started looking at functions in Algebra 1, let's inspect values of z by creating a chart of x values and y values, and just plug in these respective x and y values to see what z is. So in other words, when x is -1 and y is 1, if we were to plug those into the equation, -1 squared plus 1 squared, we're going to get 2 back. And similarly, if x were 3 and y were -1, plugging that in, 3 squared plus -1 squared is going to get me 10. So this gets me all the corresponding inside the tables, all the corresponding z values given our collection of x values and y values. What are some restrictions on z? Well, we know, since z is x squared plus y squared, z is always going to be greater than 0. There's no way it can be negative. Um, what do we think it's going to look like? Well, it's probably something circular because we've got the x squared plus y squared, and we'll be looking at ideas of cross sections and level planes later on. But so if we were to go and just plot all of these points on a three-dimensional graph, what we would end up getting is something that looks a little bit like this. So what is it? It's a 3D parabola. And we generated this graph. This is a graph that comes from a textbook, but uh, we are going to be using a lot of 3D graphing, and on the first part of our website, there are a number of helpful applets and graphing calculators. In particular, this one right here. This one we're going to be using today, and very quickly, moving on, we'll be using a bunch of others. But so if I were to click on Great 3D Grapher and Contour Diagram, what I get is this very cool Flash software. So I can go into Z, and I'm going to change Z to x squared plus y squared, and I should get the same type of graph back. Here's my graph, and what we have is the x-axis, the y-axis, and then the vertical z-axis, and I can rotate it around. So I'm rotating it around the z-axis. I can also flip it up and upside down. So look below it. So this is a very helpful site for us to visualize three-dimensional graphing. So we've got this 3D parabola. That's what we have. Um, let me move back. The purpose of this video is really to get a sense of graphing in 3D and what three-dimensional shapes look like. So we're going to look at a bunch more. Okay, so now we've got g, h, and k of x, and we want to think about transformations. So transformations. We know how to do transformations of graphs in 2 dimensions, but in 3 dimensions, uh, 3 dimensions, it's really just the same. Here we have x squared plus y squared plus this 3. So what's that going to do? What is the effect of this plus 3? It's going to shift it up. We'll shift it up where? It's going to shift it up. Ooh, that's a weird letter. Shift up plus 3. So it's going to shift up plus 3 in the z direction. And what about this? Here, I could write this a little bit differently. Well, no, let's not. We have 5 minus x squared minus y squared. Sure. We could write this as 5 minus x squared plus y squared. So what's the effect of this 5? Well, the 5 is going to shift it up in the z direction, and the effect of this negative, well, what does negative do? Just like in two-dimensional, it's going to flip our parabola. So now it's going to be an upside down parabola that's shifted up 5. And lastly, we've got this minus 1 inside, y minus 1 squared. What's that going to do? Well, that's going to, it's going to shift positive 1 in the y direction. So let's see what these graphs look like. So here's my G graph that's been shifted up 3. So notice that our vertex is now, instead of 0, 0, 0, it's at 0, 0, 3. It's gone up 3. Here's my H graph. The vertex is at 5 because of that plus 5, and it's going down now, parabolically shaped down because of the negative. And lastly, we've got this parabola that's been shifted 0.1 in the y direction. So now we notice instead of the vertex being at the origin, it's been shifted positive 1 in the y direction. So the transformations are rules, and understanding of transformations can be pretty much directly paralleled to from 2 dimensions to 3 dimensions. All right, let's look at some more graphs. Just the more time we spend looking at graphs, the better. And this one in particular is a great graph. So before we actually generate a graph of it, let's think about what we know. You know, what's inside here, because it's x squared plus y squared, it's going to have some sort of circle feature. There's going to be some circle because of x squared plus y squared. X squared plus y squared is always going to be greater than 0. So therefore, we're always taking e to a negative number. So what does that mean? That means that g, well, it could be 0. So e to the 0 is 1. Otherwise, e to a negative number is going to be less than 1. So our g value is always less than 1, but greater than 0, because the domain of e to something is always greater than 0. So when will it be the biggest? When is it going to equal 1? It's going to equal 1 when x and y are both 0. All right, enough preamble. I know that you want to see what this looks like. Let's go to our equation, and we have e raised to the negative x squared plus y squared. And here's, I think, a very cool graph centered around, it's symmetric around the z-axis, and it looks like this. And when we said circle features, you know, if we kind of think about cutting across, and we'll talk about these cross sections later, but or sorry, the contour sections later. But if we were to cut across here, these would be circles. Our contour lines would be circles. And as our x values get further and further away from 0, x and y values get further and further away from 0, our z values get closer and closer to 0. So we could imagine, let's change this up a little bit. Let's go from negative 5. Let's increase our window. And this is going to exaggerate it slooping downwards. And our maximum z value here is at when x and y are both 0, and our max z value is 1. And notice as we look inside the graph, we've got these kind of circular depression. All Okay, so now the idea of cross sections, and cross sections are a very helpful way for us to, without the use of computer software, and even with the use of computer software, but cross sections are a very helpful way for us to kind of understand what's going on with a graph. And the idea of a cross section is we hold x fixed and think about how y varies, and that's a cross section with a cross section of f with x fixed. And then we do the same thing with y. So then um, we're also going to fix our y value and look at how f changes with x. So here's an example. Here we have that x squared plus y squared 3D graph. And what we're looking at is a cross section where we intersect the shape with the plane x equals 2. In other words, we're taking our function f of x, y, and we're saying let's fix x at 2. And when we do that, what we get is the equation, instead of x squared, we're going to get 2 squared, or 4 plus y squared. Or in other words, z equals 4 plus y squared. And what that cross section allows us to do is to view just this section here, and it turns the three-dimensional shape into a 2D, a two-dimensional cross section. And what our cross section looks like is a parabola that's been shifted up by 4. Let's see how this can be really effective for us to get a shape of a graph. Well, before we do that, let's see this example here where we're fixing our what values. Well, what values are being fixed? We're fixing x, and we notice, here's this is x equals 0. Here's some positive value x. Here's some negative value x. And we notice that we have all these parabolas. We're having all these parabolas in the YZ planes. And then here we're fixing our y's, so we're setting y at some number. And when we set y at some number, we're looking at these parabolas that are z changing with x. So z changing with some fixed y value. So x squared plus some fixed y value. So let's just say b squared. So using this idea, let's think about what this function here would look like, x squared minus y squared. Well, if we fix x, let's say like when x is 0, well, let's do this. Here's x, and here's g of xy, and here's what our graph looks like. So when x is 0, we're going to get just negative y squared, and we know that that looks, and here we're graphing y and z together, so we're going to get something that looks like this. When x equals plus or minus 2, we're going to get 4 minus y squared. So in our z and y plane, we get something that looks like this. And we can continue to do such, but we have it right here, so let's take advantage of that. Here are our graph of all the cross sections. So when we fix our y value, our x, z graphs are all concave up parabolas, and when we fixed our x value, we've got concave down in the yz plane. So what's that going to look like? What is that going to look like? Take a second to try to imagine this. So as we get away from x equals 0, fixing x. So as we look at x values increasing, our parabolas are going to get more and more, are going to be lifted higher and higher. Still always concave down. And as we fix our y values, we're going to get parabolas that as we get away from y equals 0 are going to be having lower and lower vertexes. So we end up getting the shape that looks like this. And this should be of no surprise. So, fixing a y value, setting some y value, we have these parabolas here, which as y gets further away from the origin, the vertex gets lower. And if we fix our x values, again, we have parabolas. And as x gets further away from the origin, our parabolas have a much higher vertex. And this creates something that's called, we name this shape a saddle. Okay, more graphs. So we've seen the saddle. Now we're talking about when one variable is missing. When one variable is missing, we get something that's called a parabolic cylinder. So cylinder, think holding something, and parabola being the shape of a parabola. So we've got the parabolic cylinder z equals x squared. So the cross sections are that, in the x, looking at just x and z, we're always going to get some parabola, the same parabola, which is just x squared. And the idea is the variable that we're missing is y. Y can be anything. So no matter what y value you select, if we think about some y value here or here, anywhere along the y-axis, what you'll get is a parabola that looks like this in the xz direction. And that makes this parabolic cylinder. Another example of missing a variable, and we looked at this in the 12.1 in the first video. I've got x squared plus y squared equals 1. You see that, and you should think circle, but with radius equal 1. But now we're talking about 3 dimensions, so the variable that's missing is z. So since z is not part of the equation, z can be anything. So no matter what value of z we are, there's going to be a circle around that set point that has a radius of 1. And that creates this circular cylinder. Again, a cylinder, only instead of being parabolic, now it's circular. So let's just, get an example or two of that here. How do we graph that? Let's imagine that we're graphing z squared plus x squared equals 4. So what that would look like, here's z, here's x, sorry, that's totally wrong. Here's x, z, y. This is going to be a cylinder. Let's use a different color. This is going to be a cylinder around the y-axis. That has a radius of 4. And how we could enter this into our calculator, because we need to have it be z equals, we'd say z equals plus or minus the square root of 4 minus x squared. So let's see what that looks like. Z equals square root of 4 minus x squared. I'm not doing the plus or minus. Um, so if we take a look at this, um, this has part of the circle, and if we had the minus, it would have the minus part. Now, the reason that it looks more cylindrical, sorry, parabolic than a circle just has to do with the window, but this is in fact part of a semicircle. And if I were to put the minus in here, now we're looking at the second half of it. So again, the key thing is that it's running along the y-axis. And that's it. So really, this section is about being able to graph. We're talking about graphing in 3D. We also looked at cross sections. Talked about missing variables. And we were using computer software to help us picture these three-dimensional graphs. And this is on the Moodle site for you to use.